All right, problem 4-93. Draw the graph of the system of inequalities at right. So we have y is greater than or equal to the absolute value of x minus 3, and y is less than or equal to the opposite of the absolute value of x plus 5. Letter A. What polygon does the intersection form? Justify your answer. Letter B. What are its vertices? Letter C. Find the area of the intersection. First thing we're going to do is we're going to need to graph our absolute value inequalities here. So one thing you want to think about is this inequality still comes from the parent graph. Remember, the parent graph of this is y equals the absolute value of x. Okay, and if you think about general form here, this minus 3 is just going to take what we would have for this and it's going to move it downward. So we're going to move down 1, 2, 3. We're going to have a point right here. There is no a value there, or the a value I should say is 1. So this is going to have the standard growth pattern here for this parent function. So we're going to have a V shape that looks kind of like this. So I kind of got my sides going up there, and I'm actually going to use my line tool to make it nice and straight. So let's do, here we go. And we also have one going up this direction. Now remember, these are solid because we have the equal sign in here. The other part of it, though, that we have to look at is which side would we end up shading on. We're looking for all the y values that are greater than this expression here. So we're going to be thinking about going above it here. Now, if you're not sure which way, you can always take a point and plug it in. Let's take the point 0, 0, plug it in here to make sure it makes this true. If we said 0.00, we'd say 0 is greater than or equal to the absolute value of 0 minus 3. Absolute value of 0 is 0 minus 3 gives us 0 is greater than or equal to negative 3. That is true, so we know that we picked the correct side here to shade on. So to shade, let's see here, I'm going to use my crayon. Let's shade that in kind of a blue color here. So we're shading on this side of our absolute value function, representing everything that's all the outputs that are greater than absolute value of x minus 3. All right. I won't spend forever coloring here, even though I do enjoy it. Next part here, let's graph our other function. So we've got y is less than or equal to the opposite of the absolute value of x plus 5. When we look to graph this one, and we'll do this one here, kind of think about plotting our points, and let's use green because we already put that red point on there. Remember, this is like our k, so it's going to move it up 5 units. So our locator point goes up 5, starting at our origin, 1, 2, 3, 4, 5. So remember, k is like 5. Our h is like 0, and our a is negative 1, which means it's going to end up flipping our inequality, and it actually opens downward. So it would make this V shape. So let's get out a line tool. Let's go ahead and do that real quick. We're going to start here, we're going to go down, and we're going to start over here and we're going to go down. So you can kind of see the shape that we're making here. Now the next part of it here is going to ask us to finish graphing this because we've got an inequality here. We want everything that is less than or equal to the opposite of the absolute value of x plus 5. Remember, less than's underneath something. All our outputs that are beneath it. So let's do here, let's get out our crayon again. This one in red. So we're going to have all of our values that are underneath this line, or this V shape, I should say, since it's technically not just a line. There we go, that's fine, I like that. Stayed within the lines pretty much too. So our solution here, in the end, is going to end up being this region right inside of here, where the shading overlaps. So I'm going to color that in just a little bit different color. So we drew the graph of the system of inequalities that we have over here at the right. It says, what polygon does the intersection form? Well, to me, that kind of looks like a square or a rhombus, so we could write that down. So it looks like a square or a rhombus. You could say a rectangle. Just depends on what it looks like to you. Now remember, rhombus has 4 equal sides. A rectangle has 4 right angles, and then a square is the combination of both of them there. In this case here, if we locate our vertices, we've got vertices at several different points. We've got one at the point -1, -2, -3, -4, 1. We also have one at 1, 2, 3, 4, 1. We've got one at 1, 2, 3, 4, 5. So we have the point 0, 5. And 1, 2, 3. So we have the point 0, -3. Those are the vertices of this shaded region. It says find the area of the intersection. Well, in order to find the area, we're going to have to know the lengths of the sides. A couple ways that could be done. You could use your ordered pairs that you have here, find the distance using the distance formula, or I'm going to look at it kind of from the Pythagorean theorem perspective. I've got, this would be like the center of this shape that we have, and right here, if we come in from each of those here, we've got a right triangle. So the length that we have from the point in the center to over here, that would make this 4 units. That would make this one 4 units. So 4, 4. This would have to end up being 4 radical 2, or you could do the Pythagorean theorem to come up with that. Well, if this one's 4 radical 2, then this one's also going to be 4 radical 2 because this is 4 by 4, and then we'd have 4 radical 2. To get the area, we're going to do 4 radical 2 times 4 radical 2. Well, we'd have 4 squared times radical 2 squared, which would be 16 times 2, and we get 32 square units. So the area of the intersection would be 32 square units. You do have to come up with all this information, though, before you can come up with this answer. If you have questions, this is problem 4-93. Please make sure that you take the time to ask your teacher. Otherwise, this is Mr. Boyd signing off. Hope this helped you out.